All right, what is up, guys? I am here to show you another buffer overflow. This one a bit of a follow-up to, if you guys saw my previous buffer overflow video featuring TryHackMe, I'll include that in the description below. For you guys that have done some buffer overflows before on Windows, you could start with this video if you would like, but if you are a little bit newer to this stuff, check out that video first in the description below. And this would be a good follow-up to that, because this one is a lot more, even more so OSCP-like, I would say, after having taken the OSCP. Because in this one, you get a box here. This is Brainstorm. And it says, reverse engineer a chat program, write a script to exploit a Windows machine. This is a very, this is the scenario that you're going to get on OSCP if you get a Windows buffer overflow. They're going to give you, it's just going to be another box, right? It's going to have an IP address, same as anything else. And what you're going to need to do is actually get a copy of the service that is running on that server, stand it up in your own test environment, and get a working buffer overflow payload working, and then you can use that on the remote system. But first, you want to get the buffer overflow code execution on in your test environment. So that is, that whole process is what I'm going to be showing you guys in this video. So we start here with the IP address, and that's pretty much all we know here. We run an Nmap scan. That's the very first step, of course. I'm sure all you guys know that. I'm not going to include that step in this video because, it takes some time to run, honestly, and not too much to learn from that. We're just going to run on all ports, and we find that there's 6 ports open, but the one that we really care about is, well, I guess there's 2, right? There's port 9999, which is what the chat service is actually running on, and I'll show you that here, right? So we can connect to that with Netcat. And we see this banner right here. You enter a username. So say I enter that, and then you can just type any kind of message. And that's basically how this works. And you can just basically keep endlessly sending messages there. So the way we're going to do this is it's going to be a little bit different. We're going to actually, and to save you guys time, I'll tell you this much, right? We're going to actually target not this initial username field here, not this one. We're going to actually target this message for buffer overflow. Now, of course, if you didn't know that, you would try both of them and see what you're able to get. But to save you guys time, this is what we're targeting here, okay? Now, like I said, we want to stand this up in our own local environment, because the problem is if we just try to exploit this, we're going to be doing this blind. We're going to have to reset it a million times, and we're not going to have access to seeing what's in the registers, which is, of course, essential, as well as, we wouldn't know anything, right? Be completely blind. So that's why we stand up our own environment. So what I've done already as a preliminary step is I have grabbed, let me just show you, a Windows box. This is a Windows 10 machine over here on this second monitor that I have set up here. And I've installed Immunity Debugger on it as well. But now the next step is we need the vulnerable software on this machine in order to actually test this, right? Now, how would we go about doing that? Well, there's a number of ways. If it's a commercial software, what you can do is just download it, off of GitHub or off of SourceForge or wherever you can find it, or maybe off their own website. Now, in this case, they made it really easy for you, because when you run the Nmap scan, another thing you'll see is port 21 FTP is running, and you do have anonymous login on that. So you can just do FTP to the box, type anonymous, and the password also anonymous, right? Now we're logged in. See what's here. There's a directory called chat server. So if we go into there, we can see that there's 2 files. There's a chat server executable, and there's also a DLL file, a dynamic link library file. Basically what that is a dependency that this chat server program is going to need to use. So basically what we could do is do a get, and we grab both of these files, and we we'll then have it on our Kali box, and we can just use drag and drop it over on our Windows box. Now that's something I've already done to save time, but that's basically what you would do. So what's important is I need to see the IP address of this, and it's 192.168.1.118. I guess an important thing to note here in my setup is I have these virtual machines, both of these here. This is my Windows box and my Kali box here. I have them on the same network. That is essential, right? So when you go into settings, if you're using VirtualBox, network, you're gonna make sure you can use either bridged or NATed. In this case, I have bridged, but NATed works as well. I was just having some problems with that. Otherwise, that's probably the way to go, the ideal way to go, just so it's not on your local network with your other devices, your real devices. So either one of those, as long as they can communicate to one another, right? So we can quit out of the FTP here since we don't need to do that step. I've already done it. And I can check my IP address here. This is my TryHackMe one because I'm connected to the TryHackMe network as well. I want to use this ETH0 interface here so that it's on the same network. And that's going to allow me to interact. And sorry, I didn't switch my monitors back over here to this. So what I'm trying to show you here is that this is my IP address here, not the ton0. That one is the TryHackMe IP address. This ETH0 interface is going to be my local IP, and that's the one I'm going to be using when communicating to my Windows machine. So with that established, we can see if we go back to the Windows box, we have everything set up here. So now we can just run this process, right? File, open, and we'll open chat server exe. And there you go. You load it. Now you hit the play button to make sure it's running. And now we're going to test this out, right? To do that, come back over here. All you need to do to verify that it's working is you can use Netcat to connect to it the same way we did to the TryHackMe server. But now we're going to put in the IP address of our Windows box. It'll be running on that same port there. And there you go. We see the banner. That means we're able to connect to it. So, of course, the first step is always fuzzing, right? Always going to be to fuzz the server. Now, the thing about the fuzzing is that we're going to have to modify. If you watch the previous video in the description below on the buffer overflow stuff, we're going to have to modify that exploit to get it to work. Because of, like I was showing you guys with this, right? It's a multi-step process. You have the username, you put in a username, and then you have the message, and the message is what we're going to be overflowing, right? That's where we're going to be passing our payload into. In the case of the previous one, you just straight from there, you had a little prefix, and then after the prefix is where your payload went. So I'm going to copy over those scripts, right? Like I said, the amazing thing about that, those boxes on TryHackMe, they gave you an amazing template you could port over to any buffer overflow. Now, with that being said, you might need to make a few modifications depending on the situation, as we will do here. You'll see in a second. So I'm going to copy all of these to the current directory, all three of these scripts here. Now, the next thing that I'm going to do from here is I'm as the root account, so I want to make sure that my Kali account has ownership of them. So do that. And I like to fire up VS Code. You can use Vim. I used to use Vim all the time, but I just really started to love this editor, so I'm going to use it here. And here you go. We have our fuzzing script. Let's see if I can make this a little bit larger. It's probably kind of difficult for you guys to see, perhaps. And I'm trying to do this on the fly because I just now thought of this. I think it might be in preferences. Normally it might be in something like, I don't know about theme. Maybe if I just go to the settings and type font. Here we go, font size. Let's make this 18 should be good enough. There we go. That should be pretty easy for you guys to see, I would think. So with this is like what we use in the previous box, right? I'm going to need to make some modifications, of course. The first thing, goes without saying here, but we're going to need to change the IP address to the target box and the port as well to the target port. Now, like I said, we don't need any prefix in this case, so I'm going to remove that. And now that's sufficient there. But with this fuzzer payload here, what it's doing is it's just fuzzing the initial thing. Now, this isn't going to work for us because there's two parts to it. It's not just simply sending data. First, you have the username, then you have the message, and then you're endlessly in the message. So the way that we're going to modify this for our particular situation is we're just going to add like a little bit here. And I prefer to do things in Python 3. So what I'm going to show you here is the Python 3 way of doing it. But by all means, you can do it in the Python 2 way, but it's going to be a little bit different syntactically speaking. So what we're going to do here is I'm going to start by, sending data for that username part, right? And in Python 3, this is one of the distinctions. You have to have it as bytes. And I'm just going to send some arbitrary data right here, right? It doesn't too much matter what I put here. This is just what I'm going to do. Now, this part is also important. You have to have this type here, this Latin 1. You could probably use some other keywords here, but this is the one we used in our previous example, right? So I'm just going to use that. But you definitely have to have something here. So after that, I want to make sure that it's receiving it. So s.recv 1024. And then at that point is where we can do the fuzzing, right? Because then we're in the message. And from there, what I'd like to do is just keep fuzzing it until we opt to quit out. And so when we want to do that, we can just do bytes and then send it quit. And then return, carriage return line feed is basically the enter key. So we're simulating pressing the enter key if you want to think of it that way. Let's make sure that we get our quotes properly where they need to be. And again, we're going to do s.recv 1024. And we'll finish this with an s.close. Make sure we're closing the connection after we're done. And yeah, that should be pretty much what you would need here to account for this particular program. We just need to make some slight modifications, right? So let's save this and go ahead and run it. So I'll do Python 3 fuzzer.py, and then we can come over to view it. And before I run this, there is one little preliminary step that I should always be doing that I kind of forgot about here. I'm going to do it now, is setting up our Mona configuration. And in order to do that, I know this is really small, and there's nothing I can really do about this as far as I'm aware. But if you just look right here where my cursor is, where I'm highlighting right now, I'm going to do this to set up a working folder. Just make stuff easier to work with from here. And that's how you know it did it properly. Go back to the CPU window. And yeah, we'll run the fuzzer.py. I'm doing that on my attacker box. And I'll show you what I'm looking at here. It's fuzzing it at the moment. And it's just going to keep going until it crashes the application. So this is the part. It takes a little bit to run until it crashes it, right? It depends on the program. This is what's going to help us determine the offset. And I see a bunch of things happening in the corner of my eye. And yep, it did crash, right? At the corner of my eye, this is what I saw. All this went away, and you had this here. And saying that there was an access violation when executing. Basically, we overflowed the buffer at this point. So what we're going to do from here is now we need to determine the offset, right? And made a little jump cut here. I keep forgetting to switch between the screens so you guys know what I'm looking at. So basically what I'm going to do, we determined that we crashed the program at 2100 bytes. I'm going to come here. I'm going to use the Metasploit script built into Kali and pass it -L 2100 bytes because that's where it crashed at. It's going to generate a unique string that's 2100 bytes long. If I go into that exploit template, I'm going to paste that in to the payload here, right? And from there, what I'm going to do, I modified the IP address and port for our current situation, and I just need to make some basic modifications. So all I did was I added these 2 lines after the connect, because remember, we want to inject our payload into the message, not into the username part. So I'll just do this here so that it passes in some arbitrary data into the user. Now we're into the message, and that's where we actually inject the buffer, right? And the buffer includes all this stuff. What's important right now is it includes this payload here. It's going to send this long string, and we're going to be able to use that to determine what the offset is. So save that, and I'm going to go ahead and make sure before I run this exploit, I'm going to make sure that this is up and running properly again. So open and attach to chatserver.exe. So run a new instance of it. And once I hit the play button, it is running. So now coming back here, just so you can see what it looks like from the attacker end, you will run the exploit and it'll just say that, say done. And now when I go back here, it did crash it again. So here's where we can use the Mona script to determine where that offset actually was. So I'll show you here. Basically down here, I'll do this, find MSP-distance, and then number of bytes that crashed the program. Remember, in our case, that was 2100. Pass that in, hit enter, and then what you need to pay attention to here is EIP, the EIP part. This line here, offset at 2012. So that is the offset that corresponds to EIP, which is what we want to control. So we can control what it does next. That's the instruction pointer, right? So going back, we can modify our exploit once more and tell it 2012. And then we can also tell it in this return address, let's supply 4 Bs. So what that's going to do is it's going to get the offset, or, it's going to go all the way, 2012, overflow the buffer, and then in EIP, it's going to put 42, 42, 42, because that is the hexadecimal representation of the capital B character. So upon doing that, what we need to do is determine any bad characters. And that is why we have this other script here. If you look at the 3 scripts, right, you have this all chars. So I'll do Python 3 all chars. And that will generate all the characters in hexadecimal, excluding the null byte, because that's pretty much universally a bad character. The string terminator is what that is. And that is what we would then supply as the payload instead. So doing that, let's see how I can quickly go over there. There's a lot going on. Here we go. There you go. That's what you'd have as the payload. And then is where we come in with some more Mona magic, if you will. We're going to use it to generate a byte array so it can compare and help us determine the bad characters. And so then if I jump back over to my Windows box, I can show you what that looks like. It's going to be as simple as running this. We're going to give it the null byte. And you'll see something along these lines that it wrote to the file, to both a text file and a binary file. So everything is good there. So jumping back over here, we will save what we have here and run this. But over on the other monitor, all I'm doing is I'm resetting it, right? I'm opening the chat server again, because remember, we crashed the program, so we got to make sure that the chat server is running. So I'm doing that. I'm hitting play. And now I'm going to go ahead and run the exploit once more. So I did that. It crashed the program. Big surprise there, right? And so now what we see here is EIP is 42, 42, 42, 42. Perfect. That means we are able to control that register. So what we really want to pay attention to is the value of the stack pointer ESP. Now, in order to look for any of these bad characters, we're going to use Mona compare and pass in the stack pointer. And if you watch the previous buffer overflow video, everything is exactly the same as it was in that video. So we're going to use this command to do it. Now, of course, this was when we were doing it in that example. It was in the OSCP folder. It's just going to be whatever the program's called because of when we set our working folder. Remember the first thing we entered down in this box, the Mona config thing? In this case, it's going to be called chat server. And if you really are unsure, you can open your file explorer, go into your C drive, the Mona folder, and you can see what folder it is, what it's called. But in our case, it's going to be under chat server. And here's where we're going to supply the stack pointer here. So let me copy this value and paste it in right here. And so when you see unmodified, that means there were no additional bad characters. So in this case, luckily, it's pretty simple. Only the null byte is the bad character here. So that'll save us some time, right? So the next step we need to do is we need to determine a jump ESP that we're actually able to use anywhere in the program. And once again, Mona is our friend for this. So come down here, and this is where we supply our bad characters. In this case, just the null byte. So we put that here and run this. And so here it's kind of hanging, but we're going to need to take a look at the log. And what we should see is all of the jump ESP commands that it identified. And we're going to look for one in particular that doesn't have any protections against it, right? No DEP, no ASLR, anything like that. So window log data is the window that we're interested in. Let's go ahead and full screen this, easier to see. There's a number of options that we have. Really, any of these three will suffice. And an interesting to note thing here is that this is in that DLL, actually. This is in that link library that we supplied along with the executable. So we're going to actually be taking advantage of this DLL to actually get the code execution. So let's take this first return address here. And this is where I like to utilize a notepad just to quickly have as a little reference here. So going back over here, I just typed in, and I don't know if you can see, that's pretty small. Let me try and maybe zoom in, right? Zoom on in. This is where I just typed that in little endian format, right? So that means you take the last two characters and then the previous two characters and the previous two characters and the previous two characters. So if you're confused about little endian format, check the video in the description, the previous buffer overflow one. I explained that in a little bit more detail. But we got the return address in little endian. So we can copy that. We're going to put that into the exploit instead of these B's, right? That's what we want the return address to be. And so once we have done that, then we can start padding it with some no-ops as well for good measure. You pretty much always want to have a no-op sled just so it doesn't step on itself and you ends up messing with your payload, which is, the payload is something we're about to generate here in a second, so just bear with me. So we can kind of get rid of all of this, right? Because we're about to generate our payload to connect back to our system. And the way that we'll do that, we're going to use MSF Venom for that purpose. So in our case, This is why it's good to take thorough notes, right? I'm not having to memorize any of this stuff. I have it. All I have to do is copy, paste, and replace what needs to be replaced, right? -B, supply it the bad characters. The null byte was the only one in this case. Whatever port we want to listen on. Let's do 1, 2, 3, 4. Why not? Extra space there. Not that it really matters, but I like it to look clean. And then we have lhost. I can't remember what my IP was, so let's just take a look. And remember, like I was saying, not the TryHackMe one, but the local IP in this case. So we do that and exit out of there. And yeah, this is pretty much the command we're going to use to generate our payload. We'll give that a second to run. And while that is running, what I'm going to do is I'm going to come over here. I'm just going to restart this so that it's ready to go. And now it's listening, it's running, and this has completed. So I'm going to copy everything from the quotes all the way to this last quote here. And I'm going to input that into the payload section of the exploit. I'm going to enclose it. This is important if you do it this way. I'm going to enclose it in parentheses. Now you can generate it. See here, I generated it as a C format. You could choose the Python format, and then it would just be a little bit different, but I hate having to deal with the new line stuff and the formatting of the Python way it does it. So I just prefer the C format, and putting it enclosed in parentheses works perfectly fine. So either way you want to do it, this is just my preference here. So now upon doing that, we have our payload to connect back to our listeners. So of course, next step is we need to start our listener, right? And to do that, just fire up netcat, lvnp, and we said we're listening on 1, 2, 3, 4, so that's what we'll spawn here. So now we're listening. And after that, we can just go ahead and fire this exploit, but we got to make sure we save it. Otherwise, all of our changes wouldn't be in effect. So now coming back here, we will run exploit.py. And we need to run it past Python 3 there, right? And so upon doing that, we see we do have the connection. So who am I? We are the user that we ran it as, right? We were logged in as the IE user in this case. So yeah, we now have our working exploit on this machine. So now that we have all of this, we can exploit the TryHackMe box in pretty much the same way. There's a slight adjustment we need to make, right? Because when we generated this, we said connect to our local IP. Well, if we're running this on the TryHackMe network, we're going to need to use our TryHackMe IP address. So I can just up arrow this. Let me clear screen. Up arrow this. The only adjustment I need to make is instead of using that 192 IP address, we need to use this IP address, this 10 dot instead. So put that here. Oops. And we generate the new payload. And also, of course, we're going to need to change our IP address here to the target machine from TryHackMe. So this IP address here. So can save that. Well, we're going to need to, of course, input this this new payload that we generated, right? Of course. So let's just go ahead and do that. And so now everything should be set up correctly. Save this. And for good measure, what we can do, whoops, that is not at all what I meant to do. What we can do is copy this IP address, right? And just try to netcat to that port. And just to confirm that we are able to hit that. And we are. So now let's go back to our netcat, right? And exit out of this. And fire up our listener, make sure that's going. And now run the exploit again. And now you see we have the connection from the actual TryHackMe box. So it's very simple. Once you get it running locally, it is extremely simple to get it then going on the target server. This is the whole point of setting up your local environment and exploiting it and getting a working exploit running locally, and then how you would take that and use it to remotely exploit a server. This is very important because this is exactly the process you're going to need to follow on the OSCP exam, right? Because you're just going to have a box with an IP address and it's running some kind of application that's vulnerable to buffer overflow. You're going to need to grab that. And I think a lot of times they already give you that software on your Windows box that they supply you with. But if you didn't have it, you would just need to grab it on the internet, get it on that box. Preferably have it running on the same, definitely have it running on the same operating system, but preferably if it's a 64-bit, also using a 64-bit system or 32-bit and 32-bit. But on the OSCP, they'll make sure that all of that stuff checks out. You'll have the Windows box that's the proper, setup for whatever, they want you to exploit. But you need to make sure the environment checks out. It's the same. And then, once you get it over there, then you can get your working exploit going locally. Once you get that, you just port it over to, change the IP address or whatever, and just port it over as I did. And it should be very simple as that to exploit. So if you guys have any questions, definitely let me know what they are down in the comments section below if there's something I was unclear on. And subscribe to the channel if you haven't already, certainly if you watched the video to this point, and hit the like button to help get the message out there to anyone else who might be struggling with buffer overflows or kind of nervous about it going into the OSCP. I promise you it's not really difficult at all once you finally get a grasp of what the steps are. Take good notes, have your templates, right? You saw how quick we were able to do this because of the templates. So that's definitely what I'd say. Definitely check out some of the other videos, what you need to know for OSCP if you're going down that journey, and I will see you guys in the next video. Thanks for watching.